We are going to discuss the prime time again problem, and let's read the problem description first. So here on Earth, our 24-hour day is composed of two parts, each of 12 hours, one in AM and one in PM. Each hour in each part has a corresponding hour in the other part, separated by 12 hours. The hour essentially measures the duration since the start of the day. For example, 1 hour in the first part of the day is equivalent to 13 hours, which is 1 hour into the second part of the day. So essentially 1 a.m. and 1 p.m., which can be written as 13. Now consider the equivalent hours that are both prime numbers. So we have three such instances in a 24-hour two-part day, which is usual. So 1517, 719, and 1123. So this is a prime and this is also a prime. Notice that we do not have 1 and 13 here because 1 is neither prime nor composite. Now, accept two natural numbers, d and p, which is greater than 1, corresponding respectively to number of hours per day and number of parts in a day. So this usually is 12 and this, 24, and this is 2. D should be divisible by P, meaning that number, we covered that, and calculate the number of instances of equal prime hours and output 0 if there is no such instance. Let us look at the examples. We have 24 and 2, and we have three such instances that we discussed right here. We have three such instances. For the next example, we have 36 and 3. So this right here is D, this is P. D by P is going to be 36 by 3, that is 12. So visualizing this, we get 1, 2, 3, up to 12, which is N to 12. There are three parts. So the first part is 1, second part is 13, and third part is 25. So therefore, when we check, we get these pairs of triplets. So 2 right here is a prime number. 14 is not a prime number, so we won't check this. 3 is a prime number, 15 is not. 5 is a prime number, 17 is a prime number, and 29 is a prime number. So we are going to store this into a result. And then we check further, we get another such triplet. So we were going to add this and return 2 as our output. Similarly, this is D, this is P. We get 7 equals N. So we will check all of them. So once we check 1, we are not going to check 1 because it is neither prime nor composite. We are going to check 2. 2 is prime. Then we're going to check the next thing, which is going to be 9. This is not a prime, so we won't check this row either. Then we will check 3. 10 is not prime, so we won't check this. Similarly, we'll check all these things till 7. So essentially, there are two parts to this problem. The first part being that we need to check if a number is prime. And the second part of this problem is to traverse the input. So the input is going to look something like this. So we need to check if 1 is 1, 2, 3, and everything is prime. And then if it is, we are going to jump to the next thing. In order to solve the first problem, we will use the sieve of Eratosthenes. So what it really does is it creates an answer matrix from 1, 2, 3, 4, 5 up till n. Let's take 49. And now we are going to assume that all of these values are primes. So we are going to initialize it from Boolean true. And in the next step, we're first going to turn this to false. This also to false because 0 and 1 are not prime numbers. And then we'll start from 2. Now, we will take this 2, we will square this and start at 4. And in the intervals of 2, 6, 8, and so on, we're going to mark them false. Why? Because they're divisible by 2, so 2 is a factor for them. And in the next iteration, we're going to 3. 3 is also a prime number, So starting from 3 cross 3, that is 9, and taking intervals of 3, which are 12, 15, we're going to mark them as false because they have 3 as a factor. Moving on to the next problem, I would like to traverse this thing. I'll take two loops, one running on I and another running on J. So I will move from 0 to 12. 12 is calculated by d by p, it is n, and j is going to be the number of columns, the divisions, so this is going to be p. So 0, 1, and 2. So once the I portion is a prime number, we're going to move to the next. In order to move to the next, what we can do is we take n, which is 12, we're going to multiply it by j, it comes out to be 1, and then we're going to add I into it. So once we add I, we're going to get 12 into 1 plus 1, which is 13. Similarly, if 13 is a prime number, which it is, we're going to move to 25. How do we do that? Our n is still constant, 12. J is going to be 2 plus I. This becomes 24 plus 1 equals 25. So this is an easy formula and we can move on further. If you want to check out the code for this problem, go to the link in the description, select prime time, and you'll look into the code.